Hello everyone, welcome to another video. Now in this video we are going to look at another arrays medium level question. Now this question is really simple. Let's jump into what it is and then we'll understand like how we are going to solve this. Let me remove all this. Okay, so basically we need to sort a matrix diagonally. Now what does that mean? So let's say I have this matrix, let's say 2 1 2 2, then we have 1 1 1 2. Okay, now what we have to do is that we need to sort this. How are we going to sort this? So let's say I will create this matrix over here. This will be better. Okay, 1 2 3 1 and 2. So let's say this first element, it is already sorted, so we are not worried about that. This is also sorted, so first elements are always sorted, single elements are always sorted. Now the second diagonal, if you will see, it is 1 2, so that is also sorted. The third element, the third diagonal, if you will see, it is 3 2 2. We need to sort this, so it will become 2 2 and 3. So we'll write it as 2 2 and 3. Next diagonal is 3 1 1, so this will become 1 1 and 3. Next is 2 and 1, so this will become 1 and 2. So in this way we have to sort this matrix. Okay, but how are we going to achieve this? So let me write this somewhere. So let's start from scratch only. So what are we going to do is let me 2 2, what was it, 1 2 1 1 1 2. Okay, so this is our matrix, given matrix, for example. So how are you going to do this? So first thing that we need to take care is that whenever we are traveling through a diagonal, okay, what we'll do is that we'll keep track of whatever the elements we go through, okay, and we'll create another temporary array, okay, a vector or array, whatever you want, okay, and in that, at that particular index we will increment, so 0 1 2 3. Okay, so right now it is 0 0 0 0. This is just the values. Index is 0 1 2 3. So at third index I will increment, at second index I will increment, at first index I will increment. Okay, let me change this to 2. It will be better for understanding. Okay, so we have we don't have any 1, we have 3 2 and 2. Okay, so this will become 2 and this is 1, and all other values are 0. Okay, again 1 2, better. So now what we'll do is that we will go through this temporary array, okay, and in the same diagonal what we'll do is that wherever we found a value which is greater than 0, we will add that index to the diagonal. Okay, this is index 2, and we'll decrement this 2. So now this 2 becomes 1. Okay, again it is greater than 0, so we'll increment, we'll add this value to our diagonal. Now it is 0. Let's go ahead. Now this is 3, so this is like this, and we have our diagonal sorted. Okay, another thing that we need to take care is that while we are going through the diagonal, at first what we'll do is that we'll keep our in the first loop we'll keep our I constant. Okay, our I will be 0 and j will be changing. Okay, and in the second one our I will be changing, our j is going to remain 0. Why is that? Because when you are traveling through a matrix, okay, let's say it is something like this. Whenever I keep I equals to 0, that is I constant, we will be able to access all these columns from the beginning. Okay, but this L part which is below this, we are not able to access that when we are keeping I equals to 0. For that what we'll do is that we keep j equals to 0 constant. So at that time we'll be able to access all the columns, that's all the diagonals that start with j equals to 0. So in that way we'll be able to access the whole matrix. Okay, so this is the algorithm overall. Okay, we'll go through the diagonals. Okay, we'll find the elements, we'll keep it in a temporary array, and we'll find whatever the elements that are greater than 0, we'll add that index to our matrix back. So it is really that simple. I'm sorry, it is nothing new, it is everything that we have been doing already. Okay, so let's jump into the code and understand how this is going to work. So the first thing that we need over here is a helper function. So let me create that helper function. This will take to three things. I'm sorry, this is vector, right? This will take three things. First is going to be our matrix, second thing is going to be the row that we are going to access, and third thing is going to be our column that we are going to access. Okay, but this is going to return something, right? So what we'll do is that we'll return our 2D array. Okay, now the first thing that we need is the temporary vector. So let me create that. And what about the size? If you can see here, the maximum value that we have for any maximum value that we have in the matrix is 100, right? Less than equals to 100. So to access the 100th element, we need index 1 greater than the maximum value. Okay. Now, another thing that we need to take care is that we will be accessing these rows and columns multiple times over here. So for that, what I'll do, I will store them in some different variable. Okay, so let's say, okay, that's better. Now, the first thing that we need over here is that while I is less than, why is that? Why are we doing this? Because if any of the value, let's say I, okay, in our matrix, okay, if I is greater than the length of our matrix, okay, not length, size, I don't know, I keep using these Java functions, and j is greater than the column. Technically this is row and this is our column. Okay, so it will give us array index out of bound. So for that, j is less than 0 dot size. Okay, now that our conditions are ready, let's add the values that we find in our temporary array. So for that, what we'll do, in temporary array, okay, in temporary vector, at what index? Matrix I, j, at these index will increment. Okay, and we also need to increment I and j simultaneously, both, because we are accessing diagonals, but I will be doing over here. Okay, it looks cleaner. That's it, nothing else. Now our temporary vector is ready, but if you can see here, we have changed our I and j, right? So let's reassign them to row and column. Okay, now we need to go through our vector. So let's say not I is taken, right? J is also taken. Let's say k equals to 1. We'll start from 1 because we do not have any values that is equals to 0. If you can see, the maximum, the lowest value that we have is 1. Okay, so we'll start with 1 only because we will not be encountering 0. Okay, k is less than 101. Okay, that's the maximum size we have, and we'll increment k. Now, as you can see here, as I said, we can have multiple times same elements, right? So for that, what we'll do is that while that value is not greater than 0, while that value is greater than 0, what we'll do is that we need to add that value at index I and j, that particular index. Okay, not the value, the index we need to add. Okay, after this we'll increment I, we'll increment j, and we'll decrement our index, our value in temporary array, because we have seen that element. Okay, but since this looks not good, okay, let me change all this and I will remove this. Okay, this is much cleaner, and at the end I will simply return the matrix. Now our code is done, but this is just the algorithm. Okay, we need to access the elements as well. So for that, as I said in the beginning, first thing is that this is going to be a 0 dot size I plus plus. Okay, we'll call this helper function, will pass our matrix. In the first for loop, we have I will keep I is 0 and will keep changing the j. Okay, and the same thing we are going to do, okay, with the jth part, okay, in the second loop. But here I will start from 1 because we have already seen all the elements starting from 0th index, right? We don't need to see that again. Okay, j less than mat dot size j plus plus, and at the end again we'll call the helper function, we'll pass the matrix, the first thing. Now in this time we are not changing j, okay, we are changing only I. So I'll keep that as it is and this as it is. Now since this helper function is returning something, let me store that in our matrix only. Okay, and at the end I will simply return the matrix. Let me run this before submitting. I think I hope I did not make any mistake here. Okay, just this is I, right? Again, I hope everything goes well. Okay, let me submit this now. Okay, as you can see, it is really that simple, and I know it's a little bit slow, but we are good with this. Okay, this is enough. Like whatever we are trying to do, this is okay at this point. Okay, so I hope you understood this and learned something new, and you were able to grab in what way we are trying to use our existing knowledge. Okay. So yeah, do let me know if you have any other problems for me to solve from any other platform. I will see you in the next one. Till then, keep coding.